Hello and welcome to this video on differentiation. This is the first of 3 videos and that should cover everything you need for Edexcel International A-Level Pure 4. So this one's on parametric differentiation. Now, 2 questions on the screen. You can pause the video here and give those a go, just as a little warm-up. If you're not familiar with these, make sure you go back and look at material in Pure 3. So ideas of finding equations of tangents and normals and using the chain product and quotient rules. So when given functions are defined parametrically, you can differentiate them to find the gradient without finding the Cartesian form. Now this is why parametric equations and parametric differentiation can be so useful. Now to do this, we're going to make use of the chain rule. Now the chain rule says to find dy dx, we can find dy dt and then divide by dx dt. Now the reason this works is they kind of behave like fractions. They're not, but they do behave like them in this scenario. Okay, so the dt's cancel out and I get dy dx. So you do need to remember this because we're going to make use of it in all of the following examples. So let's get started. So find the gradient at the point P where t equals 3 on the curve given parametrically by x equals 2t squared, y equals t cubed plus 1, and t is in the reals. So we can go through each step of this. So if we can begin by finding dx dt. So dx dt just means to differentiate x with respect to t. So I get 4t. dy dt, I get 3t squared. Now combining these together, I get dy dx is dy dt, which is 3t squared, over dx dt, which is 4t. And these cancel out quite nicely, so I get 3t over 4, and this is an expression for the gradient. Now it's not in terms of y and x, which is why in the questions t can be given. Sometimes x and y could be given and you're asked to find t. In this case we have t. So dy dx, and you can write it like this to say it's evaluated at t equals 3. So that becomes 3, I know what t is, I don't need to write 3t. So that's 3 times 3 over 4, and I just get 9 over 4. Example 1, done. Okay, right, let's change the colour here. So, for the parametric equations below, find an expression for dy dx. It's not unusual to see trig equations in this sort of thing, so let's go through and do exactly what we just did. So, we get dx dt, the derivative of sine t is just cos t, dy dt. Now, here I'm going to have to make use of the chain rule and just be careful with cos. So I get minus, because the derivative of cos is minus sine, and then 2 sine 2t. So if I put these together, I get dy dx is equal to minus 2 sine 2t over cos t. And I could leave it like this, but for sake of argument, let's just cancel it. So I get minus 2, and sine 2t, remember, is getting ahead of myself here. Sine 2t is the same as 2 sine t cos t, and all of that is over cos t. So I get minus 4 sine t cos t over cos t, which means I get minus 4 sine t. Okay, and let's move on to the final question, an exam style-ish kind of question. So a curve is given parametrically by the below parametric equations. X is t squared minus 1, y is t cubed minus t is in the reals, and t is greater than 0. Find the normal to the curve when x equals 3. Give your answer in the form ax plus by plus c equals 0. So for this one, I'm going to just first of all, I know I need to find the normal, so I've only been given x, so I do need to find what t is in order to find what y is. So I'm going to start by doing that. So I get 3 is t squared minus 1, which means t squared is 4, and therefore I get t is equal to plus or minus 2. But t must be greater than 0, so I get t is 2. Now, that means I can say y is 2 cubed minus 2, which means y is 6. Okay, so I'm going to need that information to find the normal. Now, let's get on with our parametric differentiation. So, just like in the last two examples, dx dt is just 2t. dy dt is 3 squared t minus 1. Combining these together, I get dy dx is equal to 3t squared minus 1 over 2t. So now I can evaluate my dy dx at t equals 2. So I get 3 times 2 squared minus 1 over 2 times 2. So I get 12 minus 1 over 4, so that's 11 over 4. And on this side, I'm going to call that mt. Now, I actually want mn, which means this is minus 4 over 11. Now, final steps. So I get, now for my equation of the line, I get y minus 6 is minus 4 over 11 times x minus 3. Okay, now I've just got to tidy this up. So I'm going to multiply through by 11. So I get 11y minus 66 is minus 4x minus 3, like so. So 11y minus 66 is minus 4x plus 12. And if I bring this over here, just to tidy up, I can bring 4x to the other side, make it my positive. So I get 4x, add 11y, take this 12 over to the other side, I get minus 78 is 0. Okay, and that's it. So if you found this useful, please do like, subscribe, share the video. Thank you, and hope it goes all well.